Okay. So I'm hearing lots of conversations. How many of you are like remember factoring really well? Rooftop, yes. Okay. Okay, well, let's look at the first one. What did you guys get for? What did you guys get for the first one? Okay, x minus 10 and x plus 3. Okay, questions on how we get that or what we're looking for? No, we're okay on that one. All right. How about B?
X minus 4, x minus 5.
Okay.
I said x minus 5 and x minus 4, which is the right.
Does it matter what order you put it in? No. Okay. All right. How about C?
X plus 5, x plus 5. Okay.
We're happy with that order?
Yes. Of course.
Okay. All right. How about D?
X minus 3, x plus 7.
All right.
I don't really know.
Okay. All right. E and F required a little bit more. Anybody get E?
2x minus 1, x minus
2x minus 1, x minus 10.
Can you read that?
Yes. Yes. I figured a lot of you would be rusty on this one. Okay. So there's several different methods. My preferred method is factor by grouping, which anybody who was here last year knows as rooftop. Okay, you guys learned it being called rooftop. It's a factor by grouping method. Okay, so what we do is we're going to take our A term and our C term, and we're going to multiply those two together. So 2 times 10, and we get 20 out of it. And then what we're going to do with that 20 is find factor pairs that add up to our middle term, negative 21. Okay, so if I have a positive 20, but I have a negative middle term, what does that mean about those two terms? They both have to be negative. Okay, and I usually just go in order. I'll start with negative 1 and negative 20, and does that add up to negative 21? Yes. And don't you love when that happens on the first try? Okay, so I'm going to split the middle term. So 2x squared minus 1x minus 20x plus 10. Yes. Okay. So again, have I changed the problem at all? No, I haven't changed anything. All I've done was restate the middle term into two different terms. Okay, now what I'm going to do, this is what we call the grouping part. I'm going to group these first two terms, and then I'm going to group the next two terms. I'm going to change this to a plus and this to a minus, though, for factoring purposes. Okay. All right, now I have two different groups, and I'm just going to factor each one of them. So 2x squared minus 1x, what is the common term there? X. So if I factor out x, I'll be left with 2x here minus 1. Okay, and then I have negative 20x plus 10. What is the common factor there? 10. Now because my lead term is a negative, I'm actually going to factor out a negative 10. And that's going to leave me with positive 2x minus 1. Okay, because again, I'm factoring a negative out. Okay, so at this point, we want to be pretty happy because what do we notice here and here? They're the same, so that's a good sign that we did something right. So I'm going to factor out the 2x minus 1. So instead of having it in two places, it'll just be in one. So 2x minus 1. And when we factor it from the first group here, what's left over? 3x, and then when we factor it from here, left over is the minus 10. And there we go. Factor by grouping. Okay. All right. How about in F? What do we get for F? Okay. 3x, what did you say, plus 10 and 2x minus 1. Okay. Has anybody not had a chance to do this one yet? Everybody? Okay. Does anybody want to do this one together? Okay. All right. Very good. Let me bring that back up a little. Okay, so what we're going to look at now are when we have these special factoring situations. So the first one is when we have the difference of two perfect squares. Right, so again, that would be like having a squared minus b squared. And what happens is it factors into a plus b times a minus b. So what's happening when we're factoring? Well, what we're undoing, we are undoing the multiplication. Exactly. Okay, so if we recall, when we multiply two terms like this together, these two binomials, what happens is, I'll rewrite it over here, a plus b times a minus b. Right, when we start distributing our terms, we get a squared minus ab plus ab minus b squared. And what happens to those two middle terms? They cancel each other out, and that's how we get left with this a squared minus b squared. Okay. All right, so just remember, when we're factoring, we're just undoing the multiplication. So our other one, perfect square trinomial, we have two situations. We have a squared plus 2ab plus b squared. All right, so what we want to notice is that the first term is a perfect square, the third term is a perfect square, the middle term is 2 times the square root of the first and third term. Okay. And this is going to factor into the quantity a plus b, all of it squared. So again, we're undoing a multiplication. So this is like having a plus b times a plus b. And if we distribute the terms, we get the a squared plus ab plus ab again plus b squared. And so again, what happens is those middle two terms combine to give us a squared plus 2ab plus b squared. All right. So what happens then if we want to consider the other situation, a minus b squared? What do you suppose changes in that perfect square trinomial? It would become minus 2ab, exactly. So a squared minus 2ab plus b squared factors into a minus b quantity squared. Okay, so let's go ahead and apply those. We've got our first example here, 25x squared minus 1. Okay. So first thing I want to notice is there's only two terms. There is a subtraction happening. And then what do we notice about those two terms?
Perfect squares.
They're both perfect squares. All right, so difference of perfect squares. So I look at the square root of 25x squared is 5x. Square root of 1 is 1, so therefore this is going to factor into the plus and the minus. 5x plus 1 times 5x minus 1. Okay, so our next one, we've got 4x squared minus 12x plus 9. Does anything kind of stand out to you here? A and B or A and C? They're both perfect squares. Okay, so if you see a perfect square as an A term and the C term, you might want to think this might be one of those perfect square trinomials. Okay, so what I'm going to do is look real quick. The square root of 4x squared is 2x. The square root of 9 is 3. And then I want to come back and look to see if I take 2 times 2x times 3, am I going to get 12x? Yes. Okay, so the only thing I need to take into consideration though is that it's a negative. So that means when I go to do the factorization, it's going to become 2x minus 3 quantity squared. Yes?
So I know you got the 2x from that you were like multiplying to get 12, but where is that like initial 2 from? It doesn't have an x.
It comes from this pattern here.
Oh, okay.
Yep, that 2. Okay. All right. If you don't recognize this as a perfect square trinomial, can we factor it using other methods? Yeah, absolutely. Okay, so there's no harm in doing this one with rooftop or factor by grouping, or if you use the box, perfectly fine. You're still going to get the same answer. It's just nice when you do recognize it because it just makes the factoring much faster. All right, and how about our next one? 3x cubed minus 12x. Anything we notice there? It's cubed. There's a 3x in both terms. So that really should always be the first thing we look for. Is there something we can factor out of every single term? So this case there is. We can factor out 3x. And that's going to leave us with x squared minus 4. And would we be finished here? No, because what is x squared minus 4? Difference of perfect squares. So we would have to go a step further. And so we carry down our 3x, and our difference of perfect squares turns into the plus and minus of the square root of each term. Oops, that should be a minus there. Yes, Catherine. The top question up here? That one. I saw my first yawn. Now I'm going to start. Is anybody else really sleepy today? Yesterday?
So much
I'm so tired today. Okay. All right. So this next part, the whole point in doing all this work with factoring is so that we can solve equations. Okay. When we can factor a trinomial to solve for the zeros, it's very efficient, right? We have other methods for solving quadratics, but factoring is by far the most efficient way. So again, if we had something like we factored something into x plus a, x minus b, and this is set equal to 0, could we then solve for the zeros? Yeah. Yes. Okay, so this comes down to using this zero product property, which tells us if you have any two terms being multiplied by each other and the product is 0, well, the only way for that to be true is that either the first term is 0 or the second term is 0. So in this case, either x plus a would have to equal 0 or x minus b would have to equal 0. And then we would just solve. So this would mean that x would be negative a. This one would be that x is equal to b. And so two answers here, negative a and b. All right, so what does it mean, the zeros?
Solution.
The solutions, where they cross the x-axis. Exactly. Okay, so remember, quadratic equations are just parabolas, right? Which means they go symmetrically either up or down, and we're looking for the places that they pass the x-intercept, and that's the zeros. Okay, ready to try a few?
Yes.
Yes! Like it. All right. So let's look at the first one. I have x squared plus 4x is equal to 21. So what's the first thing we would need to do?
Subtract 21.
Subtract 21. Because remember, anytime we're solving these, we have to be set equal to 0. So I subtract 21 from both sides. I get x squared plus 4x minus 21 is equal to 0. And what we're hoping for is that it's factorable. Has anybody factored it already?
Yeah.
What'd you get?
X minus 3
And x plus 7. Okay. All right, applying the zero product property again. That means x minus 3 has to be 0. So that x would be 3. Or x plus 7 equals 0. And this x would be negative 7. So again, two solutions. X is equal to both negative 7 or 3. And again, this represents where that parabola is intersecting the x-axis, our x-intercepts. All right, is it absolutely necessary to write these steps out here?
Yes.
No, it's not. So if you don't feel the need to, you don't have to show it. All right. Let's look at our next one. Okay, I have 4x squared minus 81 is equal to 0. Does anything stand out about this one? They're both perfect squares. There's only two terms and one is being subtracted. Okay, so difference of two perfect squares. So square root of 4x squared is 2x. Square root of 81 is 9. And so this is going to factor into 2x plus 9 times 2x minus 9. All right. So again, if we solve each one of these, 2x plus 9 equals 0. This would be 2x is equal to negative 9, or x is equal to negative 9 halves. And what would happen when we solve the other one? We're going to get 9/2, yes. And you could write it this way, or you could also just do x is equal to plus or minus 9/2. Either one of those is fine. Okay. Any questions so far? All right. Let's see. Okay, so I've got 2x squared minus 11x minus 40 is equal to 0. I can't factor that 2 out, so I need to look at other methods for factoring. Now, you can always apply that factor by grouping, but sometimes you can sort of reason your way through. So this is one of those. 2 is a prime number, okay, and so since it's prime, I already know that I can factor this one. The first term would have to be 2x, and the second term would have to be x, okay? All right. So rather than going through the process of factor by grouping in this one, I just want to see, can we sort of just reason out what the factorization should be? All right, so now I want to look at the negative 40, and I want to look at factor pairs of negative 40 that I can plug into these two positions. And don't forget, we have a times 2 over here, and I need them to add up to negative 11. So what are some factor pairs of negative 40 that might work? Any thoughts? Yes, City?
Is it 5?
5 and negative 8. Okay, so we can try that. Again, we're sort of doing a little bit of guess and check. So if I put negative 8 here and positive 5 here, if I multiply those, I get positive 10 minus 8. Does that give me negative 11? Nope, that one doesn't.
Should you try to switch that?
Okay.
Where's 2x plus 5?
All right, so let's switch these.
Plus 5.
5 and 8. Okay, so if we switch that. Okay, now I have negative 16 plus 5. Does that give me negative 11? Yes. Okay. And I know that may have been what you meant to do in the first place. I was just kind of going through the process of that sort of checking, the sort of guessing and checking. Okay, so again, this one was not too bad to do by that method, again, because the numbers are prime. When the numbers aren't prime, I would definitely stick with, rooftop, because guess and check can get really tedious. Okay, so we've got our factorization is equal to 0. So what is my first x? Negative 5/2, and the next 0 is 8. All right. Our next one. 4x cubed minus 15x squared is equal to negative 9x. What should we do first? Add the 9x to the other side so that we are set equal to 0. Okay, 4x cubed minus 15x squared plus 9x. We are now equal to 0. Again, look through. Is there anything we can factor out of all the terms?
Yes.
X. So x comes out, which leaves us with 4x squared minus 15x plus 9. All right, so what do we have left in our parentheses at this point? Is it just a... Yeah, it's just a quadratic. Okay, we do see that we have the first term is a perfect square and the last term is a perfect square. We can do a really quick check. If we take 2 times 2x times 9, is that going to give us that 15 in the middle? No, so this is not one of those perfect square trinomials, which means, what are we going to have to do? Rooftop it. Okay. All right, so 4 times 9 is 36. I have a negative in the middle, so that means both terms have to be negative. And anybody already find the pairs?
12 and 3.
Negative 12, negative 3. All right. I'm going to split my middle term here. So 4x squared minus 12x. I'm going to do this as a plus negative 3x plus 9. And now I can group these. So let's see. I'm going to make that a hard bracket to separate it. Okay, so here's one group and here is my other group. All right, so carry the x down. Students often forget when they factor something out at the beginning and they leave it off. Make sure you carry everything down. And from our first group, what can we factor out? 4x. So 4x comes out and then we're left with x minus 3. And from the second group, what can we factor out? Negative 3. And that's going to leave us with x minus 3 again. Okay, so now we've got an x minus 3 in 2 places, so we'll factor that out. We're left with x times x minus 3 times 4x minus 3. All right, what are my zeros?
3 and
0,
0, 3, and 3/4. Okay. Should we have known at the beginning we would get 3 zeros?
Yes.
Yes, because it's an x cubed. Yes, Lola. Yeah. Okay. Alrighty, so the next part we're going to look at is solving the inequalities. The whole description is here. You don't need to write it down because guess what? We've already done absolute value inequalities. And is this any different?
No.
Not really. Okay, so the only difference is we factor the quadratic, and once we have the zeros, the whole process is exactly the same. All right. So we're just going to go ahead and jump into them. Okay. So when we were working with the absolute value inequalities, one of the things we did was we got rid of the inequality sign and turned it into an equal. Okay, so we're going to do the same thing here. With the absolute value, it wasn't always necessary. You could solve it with the inequality signs in it. Can't really do that with these. Okay, so we are going to plug in the 0. Okay, I've got this 11 by itself over here, but again, it's a quadratic, which means it has to be set equal to 0. So I'm going to move that 11 over. So I get x squared plus 2x, and this will become minus 8. And again, changing the inequality to an equal instead, 0. And then what we hope for is something factorable. And since that is the lesson today, it is factorable. Right. Anybody already have it factored?
X minus 2, x plus 4.
X minus 2, x plus 4 equals 0. So my 2 zeros are going to be 2 and negative 4. All right, so just like we did with the absolute value inequalities, I'm going to come to my number line. I've got -4 over here. I have +2 over here. It's a greater than, not a greater than or equal to, so we're going to have open circles. And so again, we know there's a change occurring at those two values. And then what do we do? Plug something in. All right, what's a nice easy number to check?
0.
0. And we're going to plug into the original. I know sometimes it's a lot easier to plug into the factored form, but if you happened to make a mistake factoring, this is where you would catch it, okay, by plugging into the original. All right, so if I plug in 0, I'm going to get 0 plus 0 plus 3 is greater than 11. Is that true or false?
False.
That is false. So we know this region does not work. All right. What's another nice number we can evaluate on 3? Okay, so if I plug in 3, I'm going to get 3 squared, which is 9, plus 2 times 3, which is 6, plus 3. Is that all going to be greater than 11?
Yes.
Yes. Okay, so again, I'm not even finding the actual sum of those terms. You know, as soon as I can see that it's true, I'm not going to do anymore. So this is true over here. And that means what happens when I check the left side of -4? It's also going to be true. And so therefore, what is our interval?
Negative infinity, -4.
Soft? Union. 2 to infinity. There we go. All right. See, pretty straightforward, yes? Yeah, because you guys have already done this. All right. Let's look at B. What is so lovely about B?
It's already
factored.
Already factored. What are our zeros? 3 and -5. Okay. Was there one that we should be careful with on this one?
The first one.
Yeah, that first one. Be careful. Okay. Yeah, it's a -x in the front, so that's going to make it a +3. All right. So just like we did before, I've got my number line. -5 is over here. 3 is over here. It's only a less than. So we'll do open circles and plug in. Again, what's our nice easy value?
0.
0. Okay, so if I get -0 plus 3, that's going to give me a +3. If I get 0 plus 5, that's going to be a 5. No. That's a false. All right. What's another nice easy value we can do? 4. Okay, so here's another little trick we can do. If I plug in +4, I'm going to get -4 plus 3. Is that positive or negative?
Negative.
That's a negative. If I plug in 4 plus 5, is that a positive or a negative?
Positive.
It's a positive. And if I take a negative times a positive, is that going to be less than 0?
Yes.
It is. So that's another little thing you can do if you're already in factored form. Okay. Alrighty. So what's going to happen if I check the left side? It's going to be true. Okay. So again, we have our interval going in 2 different directions. So we've got -infinity up to -5, soft bracket, union, and then we pick up again at +3. Okay. You guys want to do this third one on your own?
Yeah.
All right. I'll let you guys try that one. So what's happening is, all right. So what did we factor into?
X plus 7 and X plus 2.
Because I heard you first. Okay. So we set that equal to 0, which means our two zeros are -2, -7. Plug into the number line, -7, -2. What happens when we mark these places? Fill them in because we have a less than or equal to. And when we go to check, what happens?
It's in the center.
It's in the center. This is the true region in here. So therefore, our interval is
Inclusive bracket -7, comma -2, inclusive bracket.
Okay, Mira.
Woo! Did you hear how fast she said that?
He stutters.
It's hard to talk fast.
No, I can talk really fast.
Okay.
Some
Alrighty.
people call me a song.
Have we been having fun with these so far?
Well,
No? Who's saying no?
Audrey.
I'm having a lot of fun. Positive.
Okay.
Yeah.
Well, if you're not having fun yet, now the real fun begins because what's next?
Application.
Yay! Yes.
Am I the Indian period? The Indian cult period?
Indian cult period.
Remember Indian cult?
Yes, I do. I don't remember what period I had them.
I think they were.
Were they? Okay. Alrighty. So we have here a farmer who plants a rectangular patch in the northeast corner of a square plot of land. What is the important statement or the important piece of that statement? Square plot of land. Okay. So that means that this entire piece of land, it's a square. What do we know about squares?
4 sides.
4 sides, and they are all
Equal.
equal. Okay. We don't know what it is, so what are we going to do?
Make a square.
Okay.
Draw a square.
Well, we don't know what the length is, so what do we do when we don't know what a measurement is?
Put a variable in.
Give it a variable. Okay, x is easy. So we'll give this side x, and again it's a square, so that means the other side must also be x. Okay. The area of the pumpkin patch is 600 square meters. Okay, so this is our pumpkin patch over here, which is perfect since it's fall now, right? Anybody already buy their pumpkins for the fall? Well, we're gonna find out. Okay. Alrighty. So we have to think about the information that we are being given. Right now we're being given the information that this piece of land here, our pumpkin patch, is 600 square meters. How do we find the area of a rectangle?
Length.
Okay, length times width. All right, so I'm going to call this the length and I'm going to call this the width. So the area of our rectangle is equal to length times width. So I know what that area is. The problem with length and width are that they're two different variables. So I need to find some way to make a statement about those so that the variables are the same. All right, the area again is 600 meters. We're given that. I need some sort of a statement about the length. Yeah.
The length is longer than the x minus 30.
X minus 30. We know the entire side is x meters, which means the leftover piece here has to be x minus 30. All right, so now we have x minus 30.
And x minus 40.
Beautiful. X minus 40 is over here. Okay. All right. Is this a quadratic equation?
No.
It is. Can I set this up as x minus 30 equals 600 and x minus 40 equals 600? No. What did we say? It has to be equal to, what's that one number? It has to be equal to 0. Okay. The only time this works is with the zero product property. It has to be equal to 0. I've got that 600 that's all by itself on one side. And so the only way to combine it with my other terms is to distribute these terms out and then collect like terms. All right, so I get 600 is equal to x squared minus 40x minus 30x plus 1200. Alrighty. Multiply the negative 30 times negative 40. Okay, so I'm going to combine my like terms. So 600, I have it x squared minus 70x plus 1200, but I'm still not equal to 0. So let's subtract the 600 from both sides. Yay. And that gives me x squared minus 70x plus 600 equals 0. Now, once we get down to this, what we're hoping for is that we can factor. And what is today's lesson? It's all factoring. So this is factorable. Okay, are they always factorable? No. But this one is. Anybody already figure it out?
30 and 20.
What do you get?
30 and 20.
Negative 60 and negative 10.
Yeah,
all right. Negative 60 times negative 10, does that give me positive 600?
Yes.
Yes. Negative 60 plus negative 10, is that negative 70?
Yes.
Yes. When you add them? Okay. So what are my two x values? 60 and 10. Okay. But again, we have a problem with context here. So now I look at these two. What can we tell based upon the two answers we have?
Hey.
Oh, it can't be 30 and 20.
What? This can't be what?
Did you just realize?
Oh, it's 40 and 30.
Can't be both of them. Which one is it?
It's 40 and 30.
10, right?
At this point, you're
60. Because if it's a minus 40, it can't be negative.
Okay. Remember, if we come back in here, if I plug in 10, I'm going to get 10 minus 30. Can you have a negative length or width? No. So we know it cannot be 10. So x must be equal to 60. Are we finished?
No.
No, because what did it ask for?
60 minus 40 is area of the square plot of land.
Okay, well it asked for the area of the square plot of land. Okay, so the area of the square plot of land would be what?
3,600.
Yes, or 60 squared, or 3,600. What? Square meters. Meters squared. Okay. Okay. What if I had asked for what are the dimensions of the pumpkin patch? Then what? Yes, then we would have 60 minus 30, and so this would be 30, and this one would be 20.
I was thinking about the dimensions.
Oh, you saw the dimensions of the pumpkin patch. Yes, you did. Okay. Okay, so what did we think of that one?
There was a lot to it.
There's a lot to. Oh, you can do it on your own. So, it's nice when pictures are provided for us. What do we do when the pictures aren't provided? Draw it. Okay. Does anybody in here think that you're expected to just do this in your head?
No.
No. Good. Pictures, once you get the picture down, it really shows you a lot, so don't be afraid to draw pictures. Okay. All right. Here's our next one. So, the length of a rectangular game reserve is 1 mile longer than twice the width. The area of the reserve is 55 square miles. What is the width of the reserve? Okay. So again, we are dealing with an area of a rectangle. So the area of a rectangle is length times width. All right. We know that the area is 55 square miles, so I will plug that in. Okay. So again, I'm going to come back to, we already have a rectangle drawn. So I'm going to label one side as the length and one side as the width. But again, we have the issue that there's two different variables in there, and so we need to get it down to one variable. All right. But what does it tell us about the length?
It's 1 mile longer than width.
Okay, so how would we represent that mathematically? 2w plus 1. All right, so now I can replace length with 2w plus 1. And can we leave the w? Yes. Is it now down into one variable?
Yes.
Okay. All right. Is this still a quadratic?
Yes.
Yes. All right. Same issue as before. We're equal to 55 and we need to be equal to 0. So I have to do just like we did before, distribute my terms. So 55 is 2w squared plus w. And again, I want it to equal 0, so I'm going to subtract the 55 from both sides. And we end up with 2w squared plus w minus 55 equals 0. Alrighty, I can't factor that 2 out, but it's nice because it is prime. So we do know that we're going to have a 2w times a w. Has anybody already figured out? An x minus, or w minus, yes, I know. I knew what you were meaning. Okay. All right. So we've got it factored. And so what happens when I go to solve this first one, 2w plus 11? What are we going to get? Negative 11 halves. Can we have a negative width? No. Which means what does the width have to equal?
5.
5. All right. Okay. Are we done? What did it ask for?
The width.
It asked for the width of the reserve. And what's the only thing I need to add to this?
Units.
Units. And this is miles. So the width is 5 miles. Okay. If we asked for the length, what would we do?
You plug it in.
Just plug it in. So the length is actually equal to 11 miles. Or you can divide by 55. That's right. All right. What do we think so far? Was that better?
Yeah.
It's really the same thing. It's the exact same thing as the one before, yeah. See, it's because now it's getting more familiar. Okay, this one is a little different.
Great.
All right, so this time we have the area of a rectangle and it's being modeled by the graph. So y represents the area in square meters. X is the width in meters, and we want to write an equation of the parabola. And then we're going to find the dimensions and the corresponding area of one possible rectangle, and then find the dimensions that give you the maximum area. Okay, so a lot going on in this one. Actually, you know what? I want to talk about this one first. Find the dimensions and corresponding area of one possible rectangle. So this goes into the interpretation of what this graph is representing. So we already see very clearly that the coordinate 1, 6 is marked for us. So let's talk about what does 1, 6 represent. What'd you get, City?
The 1 is the width of the rectangle and the 6 is the area.
Is the area. Okay, so we can say when the width of the rectangle is 1 meter, the corresponding area of the rectangle is 6 meters square. So then basically what happens once we pass 1, 6 and we keep going further to the right? What does that mean? If I move to the right, so let's say I come up to this point here. What's the difference between the 1, 6 and whatever this point is?
When the width is at 2, then it's the corresponding area of the rectangle is 7.
Okay,
9.
about, but it's growing, right? Okay, so as we move towards the right, the width of the rectangle becomes larger, the area of the whole rectangle becomes larger, and that continues to happen until where? The top, or the, what do we call that? The vertex. That continues to happen until we reach the vertex. And then what happens once we pass the vertex? It starts decreasing, okay? Meaning the, well, what's decreasing? The area is decreasing, but what's still going up? The width. Yeah, the width of that rectangle is still increasing, but the area starts to go down. Okay, so it's asking us to write an equation. So we'll do this part next. Write an equation of the parabola. Alrighty. So we did this last class when we have to come up with the equation based upon criteria that's given to us. Based upon what we're given, which form should we be using? The x-intercept form, right? The x-intercepts are very clear to us, but the vertex is not. So we'll use the intercept form. So that's f of x is equal to a times, again, x minus p times x minus q. All right. We're going to plug in the p and the q. So f of x is equal to a. What's our first intercept? 0. So this is just going to be x. And our next intercept is 7. So then we get x minus 7. Now I need to plug a point in that's not an intercept. So the nice clear one they gave to us is 1, 6. So I'll let y equal 6, a times x is 1, and then 1 minus 7. All right, so that's going to give us negative 6a is equal to a. Sorry, 6, not a. Which means what is a equal to? Negative 1. All right. Oh, you know what? And we're not doing this last one because we did these last time. Okay, so we have a is equal to negative 1. So that means our equation is f of x is equal to negative 1 times x minus 7. Okay. So that equation represents the area. The next part it was asking for is, what dimensions result in the maximum area? So what did we already say when we are looking for a maximum? It's at the vertex. Okay. What do we already know about our vertex?
It's the average of the two x-intercepts.
It's the average of the two intercepts. So if I have an intercept at 0 and an intercept at 7, what is my axis of symmetry? 3.5. So axis of symmetry, x is equal to, and I'm going to plug it in as a fraction, 7 over 2. Again, that was 3.5. Okay. All right. And once we've established the axis of symmetry, can we find the y value? Yes. All right, so we're just going to plug that into the equation that we created. F of 7/2 is equal to, I get -1 times 7/2 times 7/2 minus, I need a common denominator, so 7 would become 14 over 2. All right, so this is going to give me -7 over 2 times -7 over 2, which is what? 49 over 4. 49 over 4. Okay. This is a contextual problem, so 49 over 4 is really not so pleasant to interpret, so we would go ahead and simplify this. So it's 24.5 what? What's up? What's our unit? Just meters?
Square.
Remember, this is the area, so meters square. Okay. So what we just found was that a width of 3.5 meters. Yes. What is it? 4, 1.
49 divided by 4. Wouldn't that be 4.5 divided by 2?
49 point. Oh, I just did it by 2, didn't I? Okay, what is it by 4? 12.25, thank you. Okay, a width of 3.5 meters corresponds to a maximum area of 12.25 meters squared. Thank you for fixing my arithmetic. Okay. And of course, what I should do is come back and look at the graph. And what was my original answer? 24. Does that correspond with that spot?
It does not.
It does not. That should have been my catch right there. I did something wrong. Okay. But you guys caught it. Okay. Again, we're not going to do this last one. We did these last time. So that is it. Do we have any questions? Okay. What's our confidence level with this material? A 4? Is that out of 5?
Yeah.
Okay.
4 out of 10.
All right. I'll take 4 out of 5.